Hello everyone, welcome to a new video of Dr. Cat Can Code. In this video, I'm going to talk about brute force algorithms, and I will provide many useful examples that you can use to understand brute force algorithms in depth. If you stick around until the end of the video, I will show you a very interesting algorithm, very interesting algorithm that can be done using brute force strategies, which is finding the password. Okay, if you think these type of videos are helpful, make sure to like and subscribe to make it easier for you to view the next video. Thank you. Okay, so before we jump into the example, let's talk about the definition of brute force algorithms. So normally, brute force algorithm will try all the possible solutions to find the correct solution. Try every single one of them to find the correct ones. Or depending on the problem, try all the possible solutions until you find one solution that you think is correct and you can end the algorithm. So the pros of brute force algorithms they are simple, very straightforward to implement, consistent, always can find the solution because it's gonna go through all the possible solution to find the correct one. Good starting baseline for any sort of comparison with better algorithms. The cons of brute force algorithm is that it is really slow because it exhaustively covers all the possible solutions until it finds one correct one. So you may get into the situation that it's not practically feasible to find a solution because it takes millions of years or even billions of years to run through all the possible solutions. Especially true for the final example at the end of the video when I'm talking about password finding. So don't be worried. But I think that example will give you an idea of what sort of password you should have to avoid being cracked or discovered by a simple brute force algorithm. The first example using brute force strategy is linear search. This linear search algorithm simply just searching through an input list to find a specific element. I have written a Python example here where I take in the input array and then the target that I want to find inside this array. I just have a simple for loop here going through all the elements in the array and until I find the element that is equal to my target, I can return that index. If until the end of the for loop and I still don't see it, I can return -1 to say that the element is not found. It's pretty straightforward. You basically just stepping through all the elements of the list, try to compare it with the target and try to find the matching one. So obviously it's brute force. If the size of the list is n, the complexity of the algorithm is O(n). Selection sort. This is another very famous and classic algorithm in the field of computer science. And selection sort is also a brute force algorithm. It basically repeatedly selecting the smallest or the largest depending on the sorting order element from the unsorted part of the array and move it to the end of the sorted part. Okay, so if you look at my implementation of selection sort here, I'm taking the input array, I'm taking in an input array and I want to sort it. So if the length of the array is n, then I will look from I to n-1 and I assign the smallest index number to I and then I start looping from I+1 to n using the j as a counter. And over here, I'm comparing my value at j with my value at min. If my value of j is less than the value of min, now min index equal to j. And once I finish this checking, what I have in my min index is the smallest element that I seen so far from I plus 1 to n. If that is the case, I will put that to I and then put I to that index. So basically, I'm swapping list at I with list at min. Okay. And then I move to the next iteration because I know the first element is already the minimum element. Now I can move on to the second element and doing the same procedures to find the min element in the unsorted part and try to swap with the second element, so on and so forth. So this is an example. I'm taking in an input and I just using my selection sort algorithm and pop out this output. So as you can see here, you have inner for loop and the outer for loop, and the complexity of this gonna be O(n) square. Obviously, it's not just because of the nested for loop, but you notice the indexes as well. So the complexity of this algorithm is O(n) square. It's not the fastest sorting algorithm, but it works. It's consistent. It's easy to understand. It's famous. It's a good starting baseline for computer scientists to learn. Okay, so let's jump on to another example using another famous classical sort called bubble sort. So similar to selection sort, bubble sort also O(n) square and also a brute force algorithm. So again, it will try to repeatedly stepping through the list, compare adjacent elements and swap them if they are in the wrong order. This process is repeated for each element in the list until the entire list becomes sorted. So if you look at my Python implementation here, I have a bubble sort array n equal to length of array. And then for I in range n, assuming that the last I elements are already sorted because I is starting from 0. So obviously nothing is sorted yet in the first iteration, floating the largest number up to the end of the unsorted part. So can you see the main idea of bubble sort here? You bubbling up the largest number until it reaches the end of the unsorted part, and that will form part of the sorted part. And you keep doing that until nothing is left. So you exhaustively cover everything repeatedly. Okay, so the bubbling happening when I compare to adjacent items, and then I swap them if they are in the wrong order. So I just pop in an example to demonstrate that my algorithm works. And this is O(n) square as well. As you can see here, there's two nested for loop with the indexes confirming O(n) square complexity. So bubble sort, like selection sort, is in the O(n) square range. It's not super fast, but again, it's classic, it's famous, easy to understand, and a good baseline demonstrating that brute force algorithm works. Okay, it works, just not very fast. Okay, thank you for sticking until this moment. And this is the special algorithm that I advertised at the beginning of this video. Thank you very much for sticking around. If you like this video, please make sure to like and subscribe to make it easier for you to see the next video from me. Thank you very much. So in this password finding algorithm, it is a brute force algorithm repeatedly checking all the generated password up to max length T from a character set of size n until it passes the password checking function. The complexity of this algorithm is extremely expensive. It's O(n) to the power of K, so it's exponential, and it's really expensive. Well, it's lucky that this simple brute force algorithm is expensive and it's very time consuming. Otherwise, we are in big trouble. How can we hide our password against this special password finding algorithm? So I have this try password function here simulating the checking process. Probably in the real life, in the real application, it will send some sort of request to the server, and then this try password is actually a function in the server checking the decrypted password from sending from server from the client, comparing to the actual decrypted password stored in the server. So basically, that this function serving as that simulation, the checking point. So password findings, taking in the max length, which is the maximum length of the password. So, because the length can be arbitrary. For example, some device or some application have 4-digit password. Some application have like 8, 20, mix of special characters, string, letters, digits, so on and so forth. So in this simple example, the set of the characters that I potentially think about some ASCII characters, ASCII letters and digits. Obviously, with my actual real password with the underscore, it's impossible for any sort of combination to actually pass or manage to find this password. But that's not the point. So we have the nested for loop here. The outer for loop will go through the different length. For example, 1 character, 2 character, 3 character, up to a max length characters. And then I'm generating the guest password from my set of characters and the given length at each iteration in this inner for loop. And then for each of the generated password, I'm going to compare it with my try password function, simulating that it's going to be sent to the server or to the database to check. And then after that, I will return the guest password. And if it passed, so if it's matching, return true, and then I will return the guest password. It means I successfully track or find the password hidden by somebody else. Otherwise, I just keep printing fail, fail, fail with all the attempts that I have tried. Okay, rest assured, this is a very expensive algorithm. It's a brute force. It's a simple brute force algorithm checking through all the combination of all the lengths up to max length of the input set of the characters. Obviously, the input set of the character even greater than it if I'm counting the special character like underscore, vertical bar, and stuff like that. And it's extremely expensive. It's O n to power of k. Both n and k can be huge depending on the password. That's why my suggestion for setting password to ensure the security is actually having a pretty long password, because a simple brute force algorithm will take forever, or even more sophisticated algorithm, it would take forever to actually run through a combination or a subset of the combination to find the actual password. So the password finding here is you need input around 18 or 20 to actually crack this password, and it's probably takes really, really long time with this simple brute force strategy without any sort of heuristic to guide the direction of finding the password. Okay, thank you very much for watching, guys. I really appreciate your support. And thank you for being part of the Cat Can Code community. I would really appreciate it if you could like the video and subscribe to the channel to make it easier for you to see the next video. I hope you like it. See you. Goodbye. Take care.